Hi, everyone. I'm Christian Grabowski. I'm the lead software engineer at Peeractive. We are an e-commerce software innovation lab. What that means is we get to build cool apps like this one. If I can get it to just switch out for a second. And so this app is built using something that just about every talk lately seems to be talking about, and that would be microservices. And so microservices are great. They give us tons of flexibility, tons of scalability, and they're easy to manage. And it's been just quite the buzzword lately. And so quick survey, who here is deploying about, like, say, 5 microservices a day, 10, 20, 50? All right, well, we're in about the 20 to 25 ballpark at Peeractive. And so with that, we have to think of a few things, like how do we organize the source code? We could put each service in its own repo, submodule them into per project or company-wide repos, as some companies do. Or we could just have a single project-wide monorepo where everything is a local file that shares dependencies through local files as well. But they all have the trade-offs. Submoduling, you can deploy your services a lot faster, but it's a lot harder to stay in sync. And a project monorepo, it's a lot easier to stay in sync, but your deploys can take a much longer time. As seen here, that app I showed you earlier, this happened to be a recent deployment before moving over to Maestro. It took an hour, 7 minutes to deploy all of our services. And so the team ended up feeling pretty much like this the whole time. And so the solution was basically to cache everything, try to put everything parallel, make all of our services smaller, and then the last thing to come to mind was just deploy only what's changed, but still have a single source of truth. And so the traditional way to do this, you have more machines, containers, workers, building all your tests and deploying. Each service package gets its own machine. You cache external dependencies and just try to make your packageable deployments, your artifacts, smaller. And what this usually leaves out is diffing what's changed. So you're deploying a lot of code that doesn't actually need to be changed if you're having everything so isolated. So Q Maestro. Maestro is a build manager similar to Jenkins or any hosted CI/CD solutions such as Travis, Circle. It's called Maestro because the end goal is to instruct your orchestration layer on what to do, similar to Maestro in an orchestra. And so what it can do is load cache previous builds and set up your environment both with sequential things that you have to have before anything else, and then the things that you just need before you actually start your test can just run in parallel much faster. And then the real heart of it is that it builds a dependency tree out of each service and then traverses them, figures out what's changed, and then if any of the dependents of the dependencies have changed as well, and then so it traverses the tree again, building siblings concurrently. And so if a parent has changed in the tree, then all of its children will be built as well as the parent. And so there's also a test flag to say, all right, well, I broke the API contract, and I know I did. So I need to test everything just to see what else I broke, because otherwise maybe I won't know. And so you can provide run all tests, which will test everything, build and test everything, but not necessarily deploy everything. And then, so this is a crudely drawn flowchart of what Maestro does. So it reads from the config, which provides what depends on what, then clones the project, builds a dependency tree, then diffs each service using libgit2, and so it's built in Go, so it's pretty good at getting as concurrent as possible. I haven't actually found an upper limit yet. And then it flags the tree for what needs to be built, and then traverses it again to actually go through, build, test, deploy. And then as long as everything's successful, it'll exit 0. And then Maestro D, which is not stable yet, but hopefully soon, is the actual manager daemon that will take all your GitHub activities, so your pushes, you tag a release, things of that nature, and queue them up for an actual build. And so that'll just go ahead and say, hey, so-and-so pushed a new commit on this branch, just build and test, don't deploy. And then, okay, they create a pull request, do the same. Now it's merged. All right, now go through deployment. And so as of right now, Maestro D has 2 work in progress runtime environments. Number 1 being Kubernetes. We run Kubernetes in production at Peeractive, so this was a must-have for us, actually. And so it's running Maestro D as its own pod, and then it has a calling it runtime manager, which is a API client to the API server of Kubernetes, which will actually create Maestro pods and then build, test, deploy from there into your staging environment. And then, at least in our case, we have a manual trigger into production. But if you're got everything, all your new features sequestered away in such like a feature flag, it's a lot easier to just go ahead and go directly into production with those features only flag on, flag off. And the other runtime that Maestro D currently supports is just a single host Docker daemon. So it talks to the remote Docker API and will just spin up containers as need be on a single host. And so, like the before slide earlier, this is the after slide, which is running Maestro. Instead of 1 hour, this took about 5 minutes to deploy the exact same commit. And demo time. So I happen to have a build here running on CoreOS with Kubernetes, and it's just going to build a pretty basic Python app with just a shared dependency of a schema. Sorry, let me just. That good? And so it's currently running one pod called auth, which is the one that's being deployed. Actually, oh, did I just zoom in some more? Sure. Is that better? No, just a little more. All right. And so that's currently running a container called tagged as latest. Now, if I'm to run the project, run Maestro, this is actually a rather quick build, but so what it's doing currently is setting up the environment, installing gcloud so I can push my containers to the registry that it uses. Pulls latest build. It's already built the database, and it's testing auth, and it's already hit the rolling update. The placeholders are for the other service that doesn't have a deployment currently. And so currently I have verbose shut off, which would mean don't log any of the child processes to standard out. Instead, they log to a file in var log. And let me just double check the rolling updates. Should be going through. Yep, looks good. All right, so now I'm just waiting on Kubernetes. While that runs, any questions? Yeah, it's each Maestro process is actually a per project thing, but it can also be per push. Maestro D will actually handle the spawning of these, so that way with each push to GitHub or any Git repo that supports webhooks, really, it'll go ahead and build a new pipeline for that. And within the Maestro D config, you can actually specify I want a max of, say, 6 builds at a time, or N, really. So, yep. I haven't really stress tested enough to hit that. Currently at work, we have a max of 10 at a time. Yeah. Any other questions? Let me just make sure. There's an image pull there. All right, well, it seems like it's not actually pulling the image for some reason. But normally it would be able to pull the image from my registry, which in this case happens to be GKE's registry. And then it will basically, it should be the new commit hash as the tag for demo auth. I guess that's not actually working for some reason. All right, well. So roadmap, more runtime drivers for Maestro D, multi-host Docker, Mesos, AWS, GCE would be nice. There is code in there for a stable native, so that way you don't need to actually have, say, a container runtime or anything. It'll have its own internal container runtime, so each build is still isolated, but it'll just be, you'll be able to run it on your host as you would any other process. And then encrypted build time environment variables, aka secrets, so something along the lines of vault or just encrypting it itself when you put in the config. And then more data store drivers. Currently it supports MongoDB and Redis to be able to store your project configs. And so the goal will be to get etcd in console and just perhaps be able to go to something like S3, throw a config up there and pull it down when you need to. Right now it only has really on or off for log verbosity. It'd be nice to have certain levels of be able to say I need debug, I need it quiet but still give me more info and standard out, or just log to the files. Larger log buffers. Currently it's using Go's buff.io scanner to log to the files, which if anyone here uses Go, it doesn't handle very large output very quickly very well, as opposed to the reader. Possibly a web UI. Currently it's just in terminal and you can read from it, and haven't really had a need for it, but I think it'd be nice to have. And then accept multiple commands for all stages. So right now the environment stage is able to just be able to be given an array of commands and run those while build, test, check to see if it needs to be created or updated. Those are all single commands currently that you can wrap in like a bash-c and do and $&, but it would definitely be nicer to just be in the config and say this command, then this command, then this command. And then if anyone has any ideas, contributors are always welcome. Thank you.